Question 12a. A direction field is to be drawn for the differential equation dy dx equals x minus 2y over x squared plus y squared. On the diagram on page 1 of the Question 12 writing booklet, clearly draw the correct slopes of the direction field at the points P, Q, and R. At point P, x equals -1 and y equals 1. Hence, the value of dy dx at that point is equal to -1 minus 2 times 1 over -1 squared plus 1 squared, which equals -3 over 2. At point Q, x equals 1 and y equals 1. Hence, the value of dy dx at that point is equal to 1 minus 2 times 1 over 1 squared plus 1 squared, which equals -half. At point R, x equals 2 and y equals 1. Hence, dy dx is equal to 2 minus 2 times 1 over 2 squared plus 1 squared, which equals 0. The values of dy dx that were just found represent the gradients of the tangents at points P, Q, and R. At point P, the gradient of the tangent is -3 over 2. That's a rise of -3 over a run of 2. I've used some fine guidelines to help sketch this tangent as best as possible to scale. Same thing with point Q. The gradient is -1 over 2, so that's a rise of -1 over a run of 2. And again, I've used some fine guidelines here to sketch this tangent as best as possible to scale. And at point R, the gradient of the tangent is 0, so it's represented here as a horizontal tangent.